So good morning, good afternoon, and good evening, wherever you're joining us from, and welcome to another live session. Today we'll be talking about IPv6 address planning and IPv6 subnetting. As usual, we have the house rules. I believe we are comfortable with this right now. If you want to ask a question, please use the Q&A section on Zoom. If you want to just make any general comments, use the chat section. And if you want to speak, raise up your hand and my colleague or I myself will allow you to speak. So for today, it's a different session. I'm going to enable you to speak. So if you want to ask a question live during the session, we'll try to allow as many of us to speak. So if you have a question, raise up your hand. Alternatively, use the Q&A section and it helps us to track the questions easily. Before we begin, I'd like to give you an update about the event. First of all, we look at the top learners for this week. Starting Monday, we had a target to cover 3 courses, right? IPv6 Foundations, Configure Basic IPv6, and IPv6 Address Planning. So we understand we had some challenges, which I believe right now it should be much better. And if not, please give us feedback. But we've seen some improvements in the learning platform, and you should be able to catch up. All the same, we have top learners for this week, and top learners basically are the learners at the top of the leaderboard, okay? So at number 1, and I did this 2 hours ago. In case it has changed, please bear with me. Maybe you'll be a top learner next time, okay? So at that time, Mahmoud Hamdi was our top learner, and being a top learner is based on the number of points that you have, XPs, and you must also have earned the badges or the learnits. If you go to the leaderboard, you'll see the learnits column, right? So top learner, the first one is Mahmoud Hamdi. So good job on that. The second learner is, top learner is Feta Jonathan. So again, good job on that. And for both of them have 4 badges. And the third learner is Henrik Visage or Visage. Sorry if I mispronounced your name. So those are our top learners for this week. And again, as I mentioned, we understand we had the various challenges that were there, and hopefully you can be able to catch up with the rest. In terms of progress in this week, for IPv6 Foundations, we had 1,102 who have not started yet, 681 are in progress, and 249 completed the course. And like we mentioned on Monday, be careful as you complete the course, because completing the course means that you've earned the badge, right? So you need to ensure that you've passed the final exam. You can complete the course 100% progress, but you've not passed the final exam quiz. So you need to complete all the lessons and then also earn the badge. For the second course, we have 1706 having started, 151 in progress, and 175 who've completed. Then for the last course, 1830 having started, 100 in progress, 102 have completed the IPv6 address planning course. So we like to encourage you to complete the courses, right? Foundations, Configure Basic IPv6, and Address Planning. It's the end of the week, but you still have time to catch up over the weekend before the next week starts. Again, so to stay on track, complete this week's courses. At least by the time next week, we are starting next week, right? You now just focus on next week courses, mastering NDP and provisioning IPv6 configuration. So with that, yeah, we'll jump straight to the order of business for this week. which is live session 2, and it's all about IPv6 address planning. And as I mentioned, don't hesitate to ask questions. You can use the Q&A section to ask your questions, or you can raise up your hand to ask questions related to the training, right? We understand you may have issues with maybe your points and other things, but raise up your hand if you want to ask a question related to the training. Then, as usual, we'll have the spin the wheel at the end of the session. On Wednesday, we had three lucky winners getting free vouchers, right? So again, today we'll have three lucky winners who are going to get vouchers towards the Certified IPv6 Engineer Silver exam. Okay, so let's begin. First thing is a quick recap. I know this is still fresh in our minds because we covered this on Wednesday, how to write an IPv6 address, right? Or the structure of an IPv6 address. So first of all, an IPv6 address is 128 bits. And we said it has 32 nibbles, right? So a nibble basically is each character in the IPv6 address. And with the example being displayed, you can say that we have the H separated by a colon. So each of the H is a nibble, or is 4 bytes, 16 bits, okay? And each of the characters, since it's hexadecimal, it can range from 0 to 9, what we're used to in decimal, and A to F. And then at the end, you have the prefix length. So when you talk of address planning in IPv6, there are three phases that you need to be aware of, or that you need to consider. First one is you need to estimate. Estimating means that we are assuming currently you're running IPv4 in your networks and you don't have IPv6. Before you go to request IPv6 from your RIR or from your ISP, you need to estimate your needs. And how do you do that? We'll cover that in this session. Once you estimate, you procure or get the IPv6 addresses. And then once you procure, you implement your address plans based on the addresses or the prefixes that you've gotten from your RIR or your ISP, okay? So let's start with estimating how much space you need. And I talked about this on Wednesday. You need to forsake thy bad IPv4 subnetting habits. And on Wednesday, I talked about the scarcity mentality that we see when we're dealing with engineers, especially coming from working with IPv4, trying to conserve, right? And right now that you have a lot of space, we try to use the same mentality when working with IPv6, okay? So remember, in IPv4, we subnetted because we wanted to conserve space. In IPv6, we subnet because we want to optimize for routing and security. And we'll see how it's possible to create hierarchical address plans in IPv6, which is not possible in IPv4, okay? In IPv6, there's no VLSM. That's partially true because you can have different prefix length in different segments of your network, but for the most part, you'll have the same prefix length on every LAN, right? Each subnet gets the same prefix length. So apart from slightly different scenarios, for example, point-to-point links, that's when you'll have a different prefix length other than a /64. But for subnets, a subnet will always get the same prefix length in IPv6. That's a slash. A VLAN will always get the same prefix length. That's a /64 in IPv6. In IPv6, only subnets matter, right? If you remember the diagram that we showed on Wednesday, where we're showing the prefix, we'll revisit this anyways, and the interface ID. On Wednesday, we said that the interface ID is 64 bits, right? So you can have 2 to the power of 64 hosts being covered by just one subnet, or 1/64, okay? So that's why in IPv6, we don't care about the number of hosts. We just care about the subnets. And then there'll rarely be a need to expand a /64 subnet. The biggest mistake most people make is trying to fit into RIR minimums or the regional internet registry minimums. Here at Afrinic, if you're an enterprise network, you come to us, you're a member, you get a /48, no questions asked. We call this type of network an end user network, right? An end site network. If you're an ISP or an LIR, you come to Afrinic, we give you a /32, okay? So don't fit into RIR minimums. And that's why this section that we're looking at is important. You need to estimate. If you estimate and find that your estimates fall within the RIR minimums, well and good. You don't need to change anything. If you estimate and find that your needs are more than the RIR minimums, then you need to factor that in as you're making the application, and it will prevent you from making future requests and adjustments to your network by renumbering, okay? So don't fit your plans into RIR minimums. Always estimate before making the request. So I talked about IPv6 enabling us to create hierarchical networks. So here's a sample for an ISP in a country, operating in one country. The country has various regions. And in each region, we have various sites or points of presence, right? And then you have customers connected on the various points of presence, right? So these are an hierarchical structure that, and you can use this to subnet your IPv6 blocks. We'll build onto this and do an example towards the end. Okay, so we have level 1, level 2, level 3, the end networks. So if you're to have a prefix, a sample prefix for this ISP network, remember at the top we had regions. So you have regions over here. That's level 1. Level 2, you have the sites, and then level 3, okay? So same thing, your prefix will look like this. You'll have a section that holds the regions or some subnet bits that will be used to cater for the regions, some subnet bits that will be used to cater for the sites, and then some subnet bits that will be used to cater for the customers. And then the last 64 bits, that's the end prefix size, customer end prefix size. And we'll look at this in a short while. Another example, university network. So at the top, you have your ASN, and then the next level is the campus level. Campus 1, campus 2, campus N. And then inside the campus, you may break this down into buildings. You have building 1, building 2, building N. And then at the last level, you have departments, department 1, department 2, department N. And then that translates to a prefix, the way the prefix will look like, right? You'll have a certain number of bits, in this case, W, bits reserved for the campi, X bits reserved for the buildings, Y bits reserved for the various departments. And then Z bits reserved for the department prefix size. Remember, the department was the last level down there. So I hope you get the picture, right? The flexibility that we get with the IPv6 address space, since it's so large, we are able to create hierarchical address plans, and you can be able to distribute your prefixes hierarchically. So I see a hand raised from Judy Kyle. So I'll come back to that. Let me just finish this. Next one is an enterprise network. Something similar, right? We already know the drill, right? You'll have the first level as your ASN. That's the prefix you'll get, 200 something something, right? Next level is branches. Maybe you'll have HQ, branch 1, branch N. Next level can be the various services that you have, data, voice, video. Then the last level, you may have the VLANs, right? Sales, marketing, operations. If you are to view this in terms of how the prefix will look like, you'll have certain number of bits reserved for the branches, certain number of bits reserved for the type of traffic, and you'll have a certain number of bits for the departments and for the VLANs at the end. So I hope you get the picture, right? So to calculate your space, you will just need to find the number of bits that you need based on the number of entities in those network segments, right? Then choose a prefix for N networks. We said if it's an enterprise network, the N network prefix will be a /64, right? If you are doing FTTH, FTTB, or you have enterprise customers, then you're going to have a different, slightly different N network prefix. I'll show you this in a short while. Then based on all those number of bits, you come up with the size that you're going to request from the RIR, or that you're going to request even from your upstream provider or your ISP. To find the number of bits, it's very easy. You use this lookup table to simplify it. Of course, you can do the calculations, and if you understand the math behind it, well and good. But nowadays, you'll have calculators that will help you achieve this or find the number of bits that you need at each level. In terms of prefix sizes, /64, we say this is the minimum. This is the recommended prefix size that you need to assign to VLANs, right? /64. /60, this is the minimum you need to allocate to home users, right? If you're deploying IPv6 to home networks, home user networks, FTTH, etc., broadband, you need to allocate a /60 minimum. So you cannot allocate a /64 because a /64, this is just one subnet, right? So you cannot allocate a home user just one subnet based on recommended best practices, okay? So minimum means you will allocate them a /60, and a /60 enables you to have 2 to the power of 4, that equals to 16 subnets. So where did I get 4? So basically I just did 64, which is the recommended prefix size here, minus 60, the prefix that you're actually allocating. So if you allocate a /60, it means that the customer can be able to create up to 16 subnets. And that's what's recommended. But the best current practices dictate that you can also allocate a /56, okay? If you're being too stingy, this is it, /60. But if you're to follow what's recommended, /56. I know right now you're probably thinking, even a /60, this is too much, right? But again, like I mentioned, we don't have the issue of scarcity in IPv6, right? The addresses are plenty. The address space is plenty. So you don't need to worry about conserving the address space, right? So this is these two. So /60 and /56. Think of this if you want to do, if you're doing FTTH, or just home, right? Home users. And then /52, you can do this for that's not a good color. So for /52, we usually say some people decide to give small businesses, right? Or small and medium enterprises, you differentiate them from the home users, right? And you give them a slightly larger block, right? So remember in IPv6, the smaller the number, the larger the block. Just a tip there. So you can decide /52, you're giving this to SMEs, then /48, this for enterprise networks. So if you have an enterprise customer who comes to you requesting for IPv6, maybe hospital, hotel, etc., enterprise customers, you give them a /48. If someone needs more than a /48, then they have no choice than to just come to the RIR to get their own block of addresses. And then based on all that information, the end network prefix size, which is a design decision. And then, for example, the number of clients you have, you get the bits, right? At each of these levels, right? How many sites do you have? You get the required bits. How many regions, etc. You also calculate the bits that you need. So the next thing is you should also ensure that your prefixes are nibble aligned, because when you're using nibble aligned prefixes, first of all, it's easy to visualize, okay? And reverse DNS in IPv6 works on the nibble bit boundary. Remember, reverse DNS in IPv4 works on the byte boundary, right? 8-bit boundary. In IPv6, this happens on the 16-bit boundary or the nibble bit boundary. So a nibble, basically, we talked about each of the characters here, right? 2, that's 4 bits. Same thing, each of the characters, that's a nibble. So if you look at this, it's easy to see the difference if you're splitting a prefix, let's say, into /40s. I'll show you this practically with an example, and you'll be able to visualize it. But basically, sticking to nibble bit boundaries means that you're just operating on each of these positions over here, okay? And it's clean. So for the nibble bit boundary, since it's 4 bits, 2 to the power 4 means that you can have 16 values, and the 16 values are from 0 to 9, and then A to F, right? So it's always clean and predictable. But I'll show you the example of a difference between nibble, which is on this side, nibble aligned, and non-nibble aligned prefixes, okay? So you can even see the first one, we start from 0, we start at 0, end at F, 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 F. The next one, you start at 0, then you end at 3F. And the in between, the prefixes will not be as clean following the hexadecimal characters that I've displayed at the top. Yeah, so again, we've talked about this a lot, right? About you not needing to worry about the space, exhaustion of the IPv6 address space. And sometimes I usually say this is not a problem for us to worry, maybe the generations to come, right? So if you look at the current block that we're using, the 200/3, right? It has 35 trillion/48 blocks. Okay. The world population in 2050 2050, it's projected to be 9.3 billion. So based on these two values, it means that at that time, 2050, you can give each of the living human beings a /48. Not just 1/48, but 3,500/48. Okay. So you can see the magnitude of the IPv6 address space. So don't worry about wastage and depleting the IPv4 address space. Okay, so before we look at an example, is there any question? So please ask your questions in the Q&A. I see Vincent, you asked about the point-to-point links and loopbacks. We'll come to that at the end. Let me start with the Q&A if there's anything interesting. Okay, so let's look at the raised hands. I see two of them. Victor, I hope it's related to the course that we're doing right now, IPv6 address planning and the section that we've just covered. So I'm going to allow you to talk, Victor. And please be brief since we have a long queue. Yes, Victor.
Yeah, hi, hello.
Yes.
Can you hear me? So my question was,
Mhm.
are we considering the /64 as an interface ID, or it is a subnet in the sense that we want to address other, we'll be giving individual devices an IP. You get, like, are you considering a /64 a subnet or a single interface ID? That's my question.
/64 is not the interface ID because remember, you'll have your prefix, the first 64 bits, right?
Mhm.
You'll have the prefix that you get from Afrinic. Let's say, I'll just do it in red there, a /32, for example, right?
Yes.
And then from that /32, you do your subnetting and break it down to certain subnet bits, which is what I've highlighted there. So 32, it means that you'll have 32 more bits to do your subnetting, right?
Yes.
That section over there, 32 bits. And then there's a section at the end. This is the interface identifier now, right?
Yeah.
Yeah. So this, you don't need to worry about this. You can do it manually. You can do like : 1 or 2, blah, blah, blah. Or it can be done automatically. Most of the time it will be done either using pseudo-randomly EY64, which was some time back, not recommended. But by the time you get your prefix from Afrinic, the first /32, then you subnet it. Maybe you're doing this for your own office, for example. You break it down, and then you realize that the prefix you'll be allocating at your branch where you are currently is maybe a /48, right?
Yeah.
And then now you need to break this /48 into various subnets, which now are configured at the end user level, right? At the VLAN level, that's what you'll be configuring as /64s.
So it
Yeah.
means that every individual host gets a /64. That's what you.
No, not a host. So at the VLAN level, maybe.
Okay, I get it.
Yeah, your VLAN, guest VLAN. The guest VLAN gets a /64. Another VLAN gets a /64. Management VLAN, blah, 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 /64. And then based on that /64, you're now going to have hosts auto-configuring themselves with that.
Within that space.
Within that space. Yeah.
Okay.
Yeah.
Thank you.
Next one is Ebenezer. Let me allow you to talk. Okay, please proceed, Ebenezer. Hello. We cannot hear you, so I'm going to skip to the next person in the interest of time.
Can you hear me?
Yes, I can hear you.
Okay, all right. Thank you very much. So I had a challenge over the week. I am not unable to log on to the platform, the learning platform. When I try logging on, it takes me to a platform which I would like to share with you, but I don't have an attachment platform. So I don't know if I can get an email and share with you what I see when I try logging on.
Can you share? My colleague Debo will help you because for this session, I'm just taking questions regarding
So
the
probably
course
if you
we
can
covered.
share, someone can connect it to me, and I will share with the challenge with the person.
So my colleague Debo has noted. Please, Debo, can you help Ebenezer out, please? Okay. So questions relating to what I've just covered right now, or any questions related to IPv6 address planning. So Victor, lower your hand. Judy Kyle, let me enable you to speak. Okay, I've enabled Guy. Guy, you can speak. Can ask your questions related to IPv6 address planning, please.
Yes. Do you hear me?
I can hear you.
Okay, thank you. I just wanted to know regarding the 60/64. I don't understand really why allocating /64 for a need that normally will consume or we need few IP addresses. Why not allocate I don't know if you can establish a link, for example. Normally, you just need 2 IP addresses. Why not establishing /1
7.
2 7, for example?
Yeah. So remember, when IPv6 was being created, the main purpose was for us to solve the issue of address depletion that was noticed in IPv4, right? That was happening with IPv4 in the early 90s. So IPv6 was an answer to that, okay? And as I mentioned earlier on, when you're coming from the IPv4 world, we are used to saving address space because you'll be asking yourself, like, you have a /64, a whole /64, right? And then you're allocating this to a VLAN, you get. So it means that if you're doing this, you have 64 bits reserved for the interface identifier, right? Another
Yes.
64 bits here. And if the VLAN probably has, let's say, 50 hosts, so most people are usually concerned that it's like wastage, right? But the reason behind this, one of the main reasons behind this was IPv6 was meant to be, what's the right word to use? Plug and play. Is it plug and play? Or it enables it makes auto configuration easier, right? So if you configure the /64, and we'll do this next week, by the way, if you configure your /64 at the VLAN level, then hosts can auto configure themselves either using Slack. So there's a mechanism called Slack, or the stateless address auto configuration. And Slack operates at the 64-bit boundary, okay? So if you decide to say that, yeah, these 64 bits are too much and I need to squeeze it, to maybe /96 instead of /64, you're going to break a lot of things, right, in your network. So it's not recommended. And that's why, remember, initially I said in IPv6, we don't care about the number of hosts because the number of bits is enough and it's too much, right? So we don't talk about hosts. That's why we care about the subnets. Okay. So my response to you, don't worry about the space being too large and don't modify it. Otherwise, you're going to break a lot of things that rely on the 64-bit boundary. Of course, if it's a point-to-point link, we'll look at this later on. Let's say if you have one router and another router there, you can go to the level of configuring on the interface /127. But the reasons behind this are not to save space, to conserve space. The reasons are different, which we'll look at later on. Okay. So that's clear.
Okay.
Yeah. And it's something,
Okay.
it's totally, it makes sense. Even me, the first time I was looking at this, I was like, why are you reserving 64 bits? And a VLAN may have just a few number of hosts, right? But once you get used to working with IPv6, it totally makes sense. Yeah. Okay, so I'll look at Judy Kyle and then Aubrey, and then we can move on. Judy Kyle can speak.
Can you hear me?
Yes, I can hear you.
My question is related to the address planning model. Based on the hierarchical address planning model that you talked about, what should we do when the number of customers per site or region differs significantly? Because if we reserve subnet bits for each region according to the largest one, we may end up with a lot of wasted address space in the smaller regions. Or do you think it's not a problem? We just have
Yes.
to make our reservation based on the largest region, the client numbers.
Yeah. So thank you for your question. And again, if you look at the address space, like I said, it's too large. So you don't need to worry about wasting. Okay. So because for the rest, maybe just to clarify what he's asking, we looked at the hierarchical address plan. Let me move that. Maybe you get a /32, and then you decide to break this down into regions, right? And then we said you do this plan based on the largest region. So if this is 1, 2, 3, so if region 2 is the largest, then you do your plan based on the largest region, okay? So if the largest region, you do your plan right, but you have region 2 over here, region 3, sorry, over here that has way less number of customers than region 2. So I say it's not a problem because you are still covered, right? And based on the large address space, you don't need to worry about this. And that's why, as I mentioned, IPv6 enables you to create hierarchical address plans. If the space was limited as in IPv4, you'll not be doing such hierarchical address plans. You'll never have the flexibility to do this. So my response is just don't worry about underutilization of the IPv6 address space in other regions or in other blocks that you've subnetted. You never know, the regions may grow in the future, and yeah, you don't need to worry about it right now. I hope that makes sense.
Okay, it's clear. Thank you.
Okay. So lastly, I'll look at Aubrey. I'll allow you to talk.
Hi, can you guys hear me?
Yes, I can hear you.
Okay. I just quickly want to find out. So you say we assign a /64 to each customer. So just a quick one. If you have only one install as an ISP, install only one device that you need monitoring access to. The client has its own internal IT that handles their internal network. Okay. How does that? Do you still assign them the whole /64, or do you actually like train the IT
Yeah.
guy how to use the
Mhm.
IPv6 in his own network, or deploy it
Yeah.
in his own network? What would you prefer?
Yeah. So just to clarify, I didn't say that you give each customer /64. So a /64 is what you configure at the VLAN level. So
Yes.
if you are configuring /64 at the VLAN level, then it means you need a larger block than a /64. You get. So if it's a home user, for example, you'll need a /60, and a /60 gives the possibility of 16 subnets, right?
Subnets, yeah.
Yeah. And in your example, based on the customer type, you will break down the prefix that you'll get from Afrinic or from wherever you're getting it from, right? You'll have maybe a /32, break it down to maybe you have provide services in various regions or cities. So cities, then you may have POPs. And then from this level, after that, now you have customer probably, or customer type. These are number of ways you can play around with this. I'll show you at the end, right? But the main thing is you're not going to give each customer /64.
/64, okay.
Yeah, you give something
Perfect.
larger, and then based on the larger block, they can create their own subnets.
Okay.
Yeah. But I
Thank
think
you.
once we look at an example right now, it will make sense.
Yes. Perfect. Thanks.
Okay, thank you. Thank you very much. So let's move on to the example. Remember, we are still at the estimating phase. We are assuming you're an ISP and you don't have V6 and you want to request for V6 from Afrinic or from maybe your ISP, right? And you want to ensure that as you are requesting this space, you've made estimates, correct estimates, so that in the future, you'll not have to go back to request for more space, okay? So the example here is we have an ISP that has operations in 10 cities. The largest, remember from one of the previous questions, was we're talking about the largest. You're not doing the plan based on all the cities, okay? So the largest city has 50 POPs, the largest of which, again, at the POP level, remember we talked about largest city. So just one city, right? Then that city has 50 POPs. In that city, the largest POP has 2,700 clients. Okay. And then the question is, how much space should it request from Afrinic if it plans to give each of its customers a /48? So that's what we want to look at right now. Like I mentioned, it's much better to use a table, and there are many tools that can help you calculate this easily. Okay. So on the description here, we have what we just discussed. The first level is the cities, 10 of them. We have the largest city has 50 POPs. And then the largest POP in the largest city has 2,700 customers. And then each of those customers, we want to give them a /48. So the question is, what's the prefix size we're going to request from Afrinic? So let's work it through. Let's start with the city. The cities, right? So for us to cater for 10 cities, how many bits do we need? This one, I'll just check in the chat. The first answer, we move on. How many bits do we need? 4, 4, 4, 4, 4. Yeah. Great. So at the bottom here, you say for you to, okay, thank you. So for you to cater for 16 entities, you need 4 bits. And the maths behind this, I see someone said 16. That's wrong. Yeah, you need 4 bits. 16 is the entities you'll get, right? Or the subnets you're going to get based on the 4 bits, right? And you're getting 16 because this is 2 to the power 4, right? Gives you 16. Okay, so over here, we need 4 bits. Next level, the POPs. Let me check the chart. 8, 8, 8, 8, 8, 8. Yeah, great. So 8. You can see someone is doing the calculations as we move on. That's great. So we need 8. The clients in the large POPs, in the large POP. 12, 12, 12, 12, 12. Okay. 16 is the number of subnets. We are the subnet level, right? 16 subnets. And then the last one. Actually, the last one we don't need, since it's the end network size, right? So that's our /48 at the bottom. So you don't need to do any calculations for that. That's our reference point. Okay. So let's see the final calculations. Yeah, for cities, we'll write 4 POPs, the largest POP, 8 bits, 12 bits. And then the final calculation is, yeah, the end network prefix size, which is this /48. 48 minus 12 minus 8 minus 4. You get a /24. So if you do this, then you need to request a /24 from Afrinic. I hope that's clear. Okay, so that's great. So going back to our hierarchical view of our network, right, of our sample network, you see we said that the levels, right, on the left. So based on what we've just looked at the city level, we need 4 bits. And then at the site level, we need 8 bits. And then the final level will need 12 bits, okay, to cater for the 2,700 customers. So at the bottom, you need a /48, which is what we're starting with. And this is a design decision, just to clarify, right? Since this is an example, it could be anything. It could be 56. Maybe you're doing this for FTTH customers. It could also be mixed, right? Because, and that's the scenario you'll be working with, right? You may have FTTH customers. You may also have enterprise customers. You may have small businesses as your customers, right? So you also need to factor that in as you're doing your address plans. And with the large space, it's very easy to do in IPv6. Site level, you're going to do 48 minus 12, right? And it will give you /36, right? 48, this is the end network prefix size, the prefix that we're giving it to the customers, minus 12 bits gives us 36. So at the site level, you'll be configuring or be reserving /36s. Then next level, the city level is 36 minus 8, right? Which gives you /28 at the city level. Then /28 minus 4 bits, which we needed for the cities, gives you a /24 at the top. So I hope this makes sense, right? In terms of like the hierarchical view of your plan and how you end up getting the various prefix sizes at each of the levels. So I know I covered some questions. Let me see if there's any question, please. Okay, so I'll come back questions later also. So we've done the estimates. Next thing is, how do you get the prefix right? And I think I've talked about this, so I'll not spend too much time here. So either you talk to your ISP, if you are an end user, because there are various types of end networks, right? If you're an end user provider independent, or PI means that you have your own blocks, right? You have your own ASN. So you come and talk to Afrinic and we give you the blocks. If you are PA, end user PA, or the provider aggregatable, it means that you are relying on your ISP to give you everything, the connection, addresses, etc. So you make a request to them to give you an IPv6 block, which you can use internally. So lastly, I saw a hand up. Okay, it went down. So okay, Aubrey, let me cover you right now. So you can speak, Aubrey.
Hi, sorry. I just quickly want to find out. I saw someone now asking in the chat if their company only has a /48. How do they go about if it's too little for them to use currently and they didn't got these configurations and there's planning backed? How do they go about to get a bigger subnet, or how will you guys assist with that?
Yeah. So to do that, you need to make a rectification request at Afrinic, and you'll be able to be given a larger block. If you've not started using it or implementing it, you may be given a totally different block, larger block. If you've started using it, you can be given a block that is next to the block that you have, right? And we'll talk about this later on, because we do what we call the sparse allocation. We don't give blocks like consecutive blocks. So we always leave space in case someone wants to do an increment or an adjustment. You can be given a block that's next to what you have. So I hope that answers your question. Yeah.
Definitely, yeah. Cool, thanks.
Okay, great. Okay, great. So if there are no other questions, we'll move on to implementing. So we started by estimating, and then now let's implement with the exact same scenario. You've estimated, you've made a request at Afrinic, now you've gotten your block. How do you implement that? So when you talk of subnetting in IPv6, and we've somehow looked at this as we were estimating, right? There are various types of subnetting problems, right? First one is you have a /48 or any prefix, and you want to split it into a certain number of equal blocks, okay? And it's the example we used for the customers, right? You had 2,700 customers, and then you want to split a certain block to cater for those customers, okay? The other type of scenario, you have a /32. You want to break it down into /40s. You already know the resulting prefix size, right? You have a parent prefix, you know the resulting prefix size. The next example is you have 125 sites, each of which needs a /60. So what prefix size should you reserve for all your sites? Again, similar to what we looked at with the hierarchy, right? You have a number, and for that number, you need a /60. The example we did was a /48, right? So you just want to know from /60, what is the top level prefix that will cover this, my 125 sites. So in summary, the generic subnetting problem is you have a parent prefix here with the prefix length L, and you just want to get subprefixes with the L prime prefix length. That's what subnetting is. So you'll be adding a certain number of bits, right? Moving from L to the L prime, you just need certain number of bits, right? To cater for that. That's the subnetting problem. The generic IPv6 subnetting problem. So this is the example we did. Each customer gets a /48, then site level /36, city level /28, then what you're requesting from Afrinic is a /24. So going back to what we discussed, for LAN subnets, each of the subnets should get a /64 each. And then for your infrastructure, you usually reserve the first subnet, okay? Looking at the hierarchy, let's say you got a /32, and then you break it down to city level or region level /36s, 16 of them, right? So the first /36, you reserve this for infrastructure. Okay, usually it's the shorter prefix in terms of length because it's all zeros, right? If you got 2001 DB8 : /32, your /36, the first one, this one here, will just be 2001 DB8 : /36. Okay, the all zeros, and use this for infra. Then for infra, you have point-to-point links. You reserve a /64. We'll come back to this later, but configure /127. Reserve 64, configure 127. Loopback addresses on a /128 each. So in terms of assigning subprefixes, I mentioned this earlier on, you can do sequential, whereby you assign the first block to subnet 1 or customer 1, second block, customer 2, subnet 2, third block, subnet 3, fourth block. But this has a problem, right? And I mentioned it earlier on. If for one reason or the other, you want to extend this subnet here, subnet 4, it means that you either need to come to the available subnets at the end, right? Allocate subnet 12. But this means it will create a problem in terms of aggregation, right? Because there are two different subnets. It will make it difficult to aggregate, okay? But with bisection, you assign the first subnet and then skip, assign the second subnet, then skip, assign the third subnet. It means that if subnet 1 grows and you need more space, right? You just come to the next available block and assign it to subnet 1. Okay, same thing, subnet 2. If subnet 2 needs much space than, more space than it has, you extend it by combining the 7th subnet, right? And you combine these two subnets into one. Same thing with the first one. It's easy to aggregate, right? The first subnet and the second subnet. And I'll show you, we'll look at this practically in a short while, okay? Subnet 4, you do the third one, etc. So you'll have free space just in case a subnet wants to be increased in terms of the space that it has. So let's do this practically with the example that I showed you. So you came to Afrinic and we gave you this prefix 3FFF:0D 00::/24. And this prefix, by the way, it's the documentation prefix, right? It's the new, not new, starting from last year, 2024. So we got this new, it's new relative to the old one, right? Documentation prefix. The other one, you've been hearing me talk about 2001 DB8 : /32. That's the one that we've had for long, right? So a request was made to extend this to a slash. This is actually a slash, it's a /20, right? Because we, even with the example I'm giving you now, I could not have used the first documentation prefix. So that was a good thing that happened. Anyway, so let's look at an example using the allocated prefix that we have, 3FFF0D. Again, we'll do it hierarchically. We already know the various prefix sizes for each of the levels, right? Customer level /48, site level /36, city level /28, and then at the ASN level, you have or the prefix that you have is a /24. So to do this, I'm going to show you in an IPAM, IP address management system. Okay. Let me do this. Or even before we get to the IPAM, let's just break it down so that we see the various prefixes. You can use various online subnet calculators, right? Available. This one is subnettingpractice.com, but there are many subnetting tools out there for IPv6. So I'll plug in let's start with the first level, 3FF 0D00 to the /24, right? So first level we have is, so we are here, right? /24. We want to break it down into this level, the city level, right? So I need to break it down into /28. So you can see the /28s that I get, right? And it gives us 16 subnets. And since it's the increments are within the nibble bit boundary, you're going to have a clean increment, right? From 0 at this level, 0 up to, let me annotate. So you're doing your subnetting at this level here. Let me zoom. Zoom, okay. At least it will make sense, right? Once you look at this. So we're doing our subnetting at this level here. Remember our prefix was a /20, 24, sorry, 24, right? So up to this point, this is 16, right? And then this is 24. So it means this portion will never change going down, right? So our subnets will be done on the next nibble, right? Starting from 25, okay? So the first one is 0, you have 1, 2, 3, going down, right? So 3FF D30, D40, going down till you get to DFF as the last one, right? So you can see the importance of using nibble bit boundaries in this example. Next level was the city level. So now you pick one of the /28s, break it down into the prefix that will be used for the sites, /36s. Okay, so I'll pick the 10. And then I want to break this down into /36s. There'll be quite a number of them. Calculate 256, right? So now you see the level that we are at, right? 28 was here. Let me just highlight it for you so that you can see the difference. So for that specific city, you will just know that based on this nibble bit boundary over here, or this nibble, that this prefix belongs to city X, Y, etc. And that's why it's very interesting in IPv6, right? Just by looking at the prefix, you know that, hey, this is city X based on this nibble there. okay? And because we split the /28 into /36s, so subnetting will be done on the /36 boundary, okay? So again, this is 16, this is 32, and then this is 4 bits, right? That nibble bit position, 4 bits. So 32 plus 4, this is your /36. So 1, 2, 3, 0, 0, 4, blah, 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 till you get to F at the end. One 156 of them, right? Since remember it's we're using 8 bits, right? So you'll have F, and yeah, that's your final prefix. Okay, so I hope it's clear, right? So here, just to clarify again, since it's we're breaking it down into /36 and it's 8 bits, so you'll be working on those two nibble bit boundaries, 4 plus 4, 8 bits, right? So there and there, you start from 0, 1, 0, 2, 0, 3, and then you reach at 0F, the last one. Then you start at, next one will be 1, right? 1, 1, 1, 2, 1, 3. And then once you get to 1F, yeah, 2, 1, 2, 2, 2, 3, 2, 4, till you get to the last one, FF. So I hope that's clear. I'll not go through the rest because I'll show you in an IP address management system how you break it down. That will be much clearer. So next thing is point-to-point links, best practices, right? So if you have 2 routers and you need to cater for point-to-point links, how do you achieve that? So best practice is for you to reserve or plan and allocate a /64 for each of your point-to-point links. Reserve a /64 and then configure a /124, 126, or 127. You can also configure a /64, but it's not recommended. And I'll mention why in a short while. So basically, if you have 10 point-to-point links or 50 point-to-point links, you need 50 /64s, okay? So each point-to-point link you reserve a /64 and then configure a /127 from that point, from that /64. Okay, the reason we do this is for security purposes, right? The first one is they used to happen. Nowadays, I usually say it's not that of a concern. These things used to happen like for forwarding loops. There's an RFC, informational RFC from 2001. So it was back in the day, whereby a router could forward packets continuously between each other, right? So let's say if you've configured from the same prefix, maybe : : 1 and then : 2, this other side, right? /64. So someone can send packet, maybe destined to : 3. And obviously know that this is not possible nowadays, right? So the routers will keep on forwarding this packet destined to : 3. So this router receives it. The router receives that packet and then forwards it to this router. This router forwards it. Yeah, nowadays it can't happen because for modern platforms and devices, you cannot send a packet from the interface which it came from, right? So that was the ping pong attacks, and then the neighbor exhaustion attacks, whereby someone could ping or could initiate an attack to try to reach addresses in the /64. Okay, so let me explain. If you've configured : 1 and : 2, :1::2 on that side. So wanataka could start initiating neighbor solicitations for the remaining addresses, right? There are billions and trillions of addresses, which could end up overwhelming the neighbor cache table, right? On the routers, okay? Because if you do like ping 2001 db8 : 100, for example, right? And it's not yet configured anywhere, the device will try to do neighbor solicitation. And for that communication to work, you need the source IP and the destination IP, source MAC and the destination MAC. Since there's no destination MAC, then the router will try to resolve that MAC address. And as it's doing that, the neighbor table entry will be marked as incomplete, right? And if you do this fast enough and at a high rate, then you're going to overwhelm the router and it becomes a denial of service. But anyway, this used to be a problem in the early 2010s. Nowadays, most, I can say even all routing platforms have rate limiting for this type of issues. But again, just to be sure and on the safe side, follow the best practices, right? Because you never know. So reserve your /64, but configure a /127, meaning that with a /127, you only get 2 IPs. So that's the reason behind the /127. I know if you're doing MikroTik, if you have MikroTik in your network, MikroTik will not allow you, unless the newer router OS versions change this, but we couldn't configure /127 on an interface on router OS, right? So on MikroTik, you do /127, 126, not 127, 126. So that's something you need to note. So an example of point-to-point walkthrough. I'll not cover this now. I'll just show you in the demonstration. Hopefully I'll not forget, but we'll cover it. So any questions up to this point before I show you the demo and we call it a day? Anything that you need clarified? Is everything clear? Vincent, I'll allow you to talk. Yes, Vincent. Okay, in the interest of time, Vincent, I'll disable your talking. We'll get back to you. I'll go back to Olayemi. I'll allow you to talk. Okay, let me do that. Okay, Olayemi.
Yeah, hello. Yeah, thank you for the presentation. My question is, when you were breaking down on the platform, the level 2 on that online platform, there's something that I got confused about. For the first level, /24, I could see that it started on 25th bit, but for the /36, it seems starting on the 36. That's on the platform, on that online platform.
Here.
Yes, I understand. For /24, 3FF, 3FF is already 16 plus 0D10. 0D10 is another, D is another 4. 0 is another 4. Then D is another 4, right? So I understand.
Okay, so let's start with the 28. This is the 28. At least it will be clear as you ask your question. This is 28 from 24.
So for the 28th, I know 3 triple F is 16.
Yes.
Then 0, that's 20, D 24. So D24, so you are starting on 25, which is a 0. 0, 1, 2. Yes. You are starting on the 25th here. Understand this. And for the next one that I did, yeah, the 0 here, 0, 1, 2 is on the 25th.
No, so this is the actual 28th, the /28. It happens on this subnet. So let me explain, because it's easy to understand if you break it down into bits, right? So we say 3FF, that's clear, 16, right? And then D 0 0. There's a 0 in front here, by the way. We suppressed. Yeah.
Yes.
Yeah. So this is 16. And then that nibble bit boundary, that's 20. And then this one is 24.
24.
Okay. This is fixed.
Yes.
It will not change. So changes are happening on the /20, this nibble bit boundary here. Okay.
Yes.
So remember
25th
this one.
to
Yeah.
28th.
So here you can have, if all of them are zeros, you'll have 25, 26, 27, 28.
Okay.
Okay. And then the last one, let me use a different color. I used, okay, that one. So the last one here, same thing, right? If you expand it into bits, you'll have 4 bits. Okay.
Yes.
So this is 25.
Yes.
26, 27, 28. Okay. But remember, in this position here, we are combining all this. So if the first position is 1, right? If the first bit is 1, 0, 0, 0, it means that that is equal to 1. Over here, you'll have 1. So it will be D1, what we have here. If the second bit is turned on and the first one off, then this is equals to 2. Yeah. If the third one is on, so to get 3, you'll need to turn on the second one and the first one, right? 0, 0, 1, 1. This is 2 plus 1. This is equals to 3. 4 is 0, 1, 0, 0 equals to 4.
Yes.
Hope it makes sense.
Yes, yes.
Yeah. So you can now extrapolate this to /36. So /36, basically you're using what we're doing here plus 4 other groups. Is it 4? Yeah, 28. 28 plus the next one here and another 1 position there. That's 36. Okay.
Yes.
Yeah.
So for
Good.
the /36 now, the one you did, it seems as if it's starting on the 36.
Let me do that. I hope it's still on time. Yes, let's do 36. We see. So we have a /24. No, actually, it's 28. We did 28. We want to break it down to /36s, right? I calculate. So for /36, remember we started at 28 should be. Is my color not working? Okay. So 28, if you go back again, this is first group is 16, right?
16 plus 12. Yes.
This is 32. And then 36 will be happening over here. Okay. And because you're moving from 28, you didn't move from 32 to 36. You move from 28 to 36, right?
Yes.
So it means that you'll be working on these two here. Let me over here. These 2 positions will be changing. I hope it makes sense, right? Because 28,
Yes.
yeah. So this position here, up to here, this is the 28 we got, the ones, right?
Yes.
Yeah.
Yes.
That was the /28 I was subnetting. It's what I pasted at the top, right? I hope it's what I did. Yeah, that's what I did. And then you're now
Yes.
changing between those two positions. And as I said, you'll start from 01, 02, 03. And then as you go down, you now move from 0, 1, 1, 1, 0, 1, 2, 1, 3, 2, 1, 2, blah, 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 3, blah, till you get to F, F0, F1, FF. So I hope it's clear.
Understood. So it started on the 29th bit, so to speak. 29th bit to 36.
Yeah.
Thank you.
Hope that's okay. You're welcome. I'll disable your talking. So Kinyua, you can speak and ask your question.
Yeah, can you hear me now?
Yes, I can hear you.
Okay, mine was just a brief one. You mentioned about documentation prefix. Documentation prefix, if I got you correctly, means that this is a prefix that is used in books and examples and is not rooted in real life, correct?
Yes, exactly. Yeah.
Okay, so I just needed to clarify that.
Okay, and thanks for clarifying. Forgot to mention that. Yeah, if you're doing your labs, if you're doing proof of concepts, etc., you don't want to be typing, let's say 200143 something, 43F8, which probably is Afrinix block, right? And when you go to configure, you
Correct.
configure someone else's block, right? So you use those blocks, 2001 colon DB8 colon /32, or the 3FF colon /20.
Thank you. Correct.
Thank you for the question. Victor, I'll allow you to talk.
Yeah, so my question goes back to the address plan that you have given. If you say, for example, you have regions, cities, the POPs, and then the customers, is it possible, for example, if you're an ISP that operates over maybe over different regions, like maybe in 2 different countries or 3 countries, would you still be allowed to give the same IP addresses to, like within your block? So, for example, I have an /24 that I address, for example, I'm in Kenya, Tanzania, and Uganda. Am I allowed to do that?
Yeah, because it all depends with you request a block from us, and if you are doing services in multiple countries, right? So you have your block, your first level will now be countries. And then maybe inside the country, that's when now you do regions. Yeah. So because the block that you're going to get will be announced via BGP, maybe /32 or /whatever, right? Is going to be, should be routable from wherever you're providing the services from, right?
Yeah.
So as long as you are in Africa, I don't see any problem with that, as long as you can do proper routing for the blocks.
Okay.
Yeah. For your scenario, probably you're going to get each country maybe getting a /32, right?
Yeah.
And then at a higher level, you request a either /31 from Afrinic or something larger.
Okay.
/30 or something like that. Yeah.
Thank you.
Welcome. Any question? Okay, so in the interest of time, I wanted to show you how to do a demonstration on an IPAM. But I think in the course itself, Mukom did this. So in the interest of time, I'll leave this to you to just go and play around in the IP address management system. There's the option that we use for examples is PHP IPAM, which is open source. You can go to demo.phpipam.net, then log in, and you see how to break down your prefix. But let me just do one quickly, yeah? And then we move on and end the session. So I'm on PHP IPAM. And just focus at the center, right? This is the prefix we got, /24, right? This is the prefix, and I want to break it down to /28. That was the region level, right? So I'll just come here and add a new nested subnet. And this subnet, I want /28, right? Actually, I don't want a nested subnet. I want to split it. I want to split this block, right? Into, I do this by editing the block. And I want to resize /split, and I want to split the subnet into /28. I'll get 16 of them, right? With this IPAM, you can name the prefix. My organization, I assume it's called Awesome ISP. And then this level was for the regions, right? So I'll just type region and split. So you see, it will name my subnet, right? Even on my left, you can be able to see. So I'll have region 1, 2, 3, 4, 5, 6, 7, blah, 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 till 16, right? So the first block, as we said, you need to reserve it for infra, right? So you come here, you edit it, and then say Awesome ISP infra. So that's reserved. And then for the first region, you can skip, right? You skip the first two, probably go to the third one. And this is for region 1, your first region or region wherever. Okay, I hope you get the point. The same region, you can now split it again into /36s, right? That was the next level from 28 to 36s. For this IPAM, PHP IPAM, you can't jump from go past 256. Let me confirm if that's the case. There's a certain level you can't go past. Okay, 256 is the ceiling, right? So if I wanted to go from 28 to 40, I can't do that in this IPAM here. But again, it's quite a lot of subnets. So you'd rather just do it one by one. Once you go past 8 bits, you'd rather just do it one by one. So let me do /36s for this region. This is now my region 1. You can name it wherever and then split it as it does the job. Yeah, so you see the regions, right? Now the next level was the sites, right? So inside region 3, you now have various blocks which you can reserve for the various sites, 256 of them. So you can see how we're doing this breaking of our prefix step by step, and you'll end up getting to the customer level. So for this, I'd like you to play around with it and see how you go about it. Usually we help people deploy this. We have if you want to deploy this in your network, we should have a VM, pre-configured VM, which you can provide. Okay, but that's something that I'll insist you do. Apart from PHP IPAM, maybe you use other IPAMs. There's NetBlocks or NetBlocks. There are quite a number of IPAMs which can do the job also. Okay, so unless there's any question, we've gotten to the end of our session. Victor, is that an old hand or a new one? Old. Cool. Yeah, unless there's any question. If you want to, I forgot about the Q&A. Okay. Let me quickly cover the Q&As. I hope for Frankie Bala, what's the difference between /64 and 127? I believe this answered. It was early on. If not, please, Frankie, please let me know in the chat if this question was answered. What's the difference between /64 and /127? If not, I'll answer it again. Okay, thank you. Mwagi asks, are you only limited to 3 levels, or it's just a recommendation? You're not limited to 3 levels. You can do as many levels as you want, as long as it fits within the block that you have, right? And as long as it fits your network the way it's designed. Okay, so you can do more than 3 levels. Judicael asks, based on the hierarchical address planning model, what should we do when the number of customers per site or region differs? Okay, I answered this live. I'll just mark that down. What's the best for P2P address plan? Is it /64 or 126? I believe I've answered this, Ibrahim. Point to point, please let me know if I've done that. We said you reserve a /64, but configure a /127 on the actual interfaces. So if you have 10 point-to-point links, you're going to have 10 /64s, okay? I've answered that, Ibrahim. Loopback, you just need a /128, right? And for loopback, you don't need to use different /64s. You can just pick one block, maybe a /64. You can even use a /64 if you want to, and pick all your loopbacks from there. Kinyo asks, recommended software. Okay, and this is what we covered at the end, and it's nice you pointed it out, right? Using a spreadsheet is not recommended in IPv6. Please don't use a spreadsheet. Use the IPAM. I've shown you the open source version there, which you can use to track your IPv6 assignments. I think I answered about the /64. So never assign a /64 to a customer. I think we said this, right? Yeah, if you do that and we get to learn that you went through our hands, it will be embarrassing for me, right? So minimum is /60 for your customers. And then for the VLANs, the end subnet, that's what you assign a /64. Alan, mobile operator, quick worked out example. For mobile operators, what I can mention is you are going to reserve a larger block, right? Instead of going from regions, because we started from a /64, a /24 in this example, or /32, right? Instead of going from maybe /32, you'll break it down to probably POPs but maybe you'll get the point. But from 32, you can reserve a /40 for mobile customers, because for mobile customers, the recommended prefix size is a /64, right? So with a /40, this is what you'll be configuring in the pool that's issuing out IPv6 addresses. With a /64 minus 40, that's 24 bits, right? So you can get 2 to the power of 24, which is 16 million, right? So from 1/40, you can get up to 16 million /64s. So that's what I can say for the mobile operators. That's the only difference. And even for the other network types, if you're doing provisioning centrally, you just need At the point where you're doing your provisioning, that's when you'll be doing the pools, right? Even with the examples we're working on, let's say /36 for the sites. So the /36 is what you'll be configuring in your provisioning mechanism. And then /48 will be issued from that /36. So hope, Alan, that's clear. I can request a /27, yes. But if you're requesting a /27 from Afrinic, you need to show a plan and how you've estimated the need. Because remember, by default, we give you a /32, right? If you need anything larger than a /32, then you need to have done a proper estimate. /64 per VLAN. The whole of South Africa has 64 million, not even a whole university. Yeah. So we talked about this earlier on. So don't worry about wastage. Be free to do your hierarchical address plans. Can the IPv6 planner be downloaded and used offline? Is that the demo.php IPAM? I'm not sure. Ogaba, please clarify that. Previous question answered. Okay, so let me see if we're getting to the end of this. Video recording, you can find it in the discussion forum. I'll also post this one after this in the evening. So if you go to discussions and then live session 1, you'll see the recording and the slides. Okay, I've answered the question. What is ASN at the start of your hierarchical design? The ASN basically is the prefix, right? So your organization, you want to request for a prefix from Afrinic. That's why we used ASN, because when you're requesting for a prefix, it means that you're an entity, that you have your own network, and you can be able to announce that. Or alternatively, you can talk to your provider to give you a prefix. I hope Esther, because that was close to 1 hour ago, I hope it was clear, Esther. If not, let me know and I can address that. Ogaba, please confirm. I'll mark that done. But the address planner, you can get it demo.phpipam.net. So as you said, Afrinica assigns enough space to each customer to have free space. Thus, you also use the bisection method. Yes, so we use bisection. We don't do sequential. So if you have a block, a /32, and if you come to us to get a rectification or to get more space, you'll get a block that is mostly, it's not guaranteed. I can't guarantee, but typically I'm sure you'll get a block that is next to the block that you have, and it's easy to aggregate. I'm confused. I think if you didn't have a prerequisite knowledge of IPv4, it will be, yes, for this session, you needed to have a prerequisite knowledge of IPv4. Mercy, I don't get the question. I don't know if it was covered. Kinyo, I answered your question about the documentation prefix. If you're locating point-to-points from infra subnet, does that not impact your routing hierarchy or summarization? So remember, you don't want to be allocating blocks for your internal network from blocks that come from maybe customer prefixes, right? So that's why we have our own space reserved for infrastructure. Remember in my example, I showed you the first /36, right? So you reserve that for infra. And it becomes easy to manage because you can even do your security policies based on that, on just that one block, right? Rather than if, let's say, you have a router in region 1, another router in region 2, and you're doing different prefixes for the point-to-point links, it becomes a nightmare in terms of security policies, right? Aubrey, can you please give us an example of a /127 full IPv6 address for each side of the P2P? Yes, I think Before I cover you, I'll come back to you. Let me just clear the other questions. Before we do it as the final example, transcript will be available, the recording. So you will always use the top level infra range, even in regions and sites, not using addressing which fits in those ranges. I don't get the question, Peter. Maybe if you can clarify. Okay, I think I get it. It's the same question that was asked. I was talking about, yeah, you use the same infra range, even in other regions and sites. And the reason for that is it becomes easy for you to manage those addresses and even create security policies, etc. I think I've answered that. In case I don't answer your question, please re-clarify. Questions answered. That's good. The sessions, I'll share the link in the discussion forums. Yeah. Is it an issue to advertise a /38 since it's not on the nibble boundary? I guess a /36 would be better. Yes. Yeah, totally. /36 is better than /38 in terms of advertising for the reasons of reverse DNS. Brian, the link of Afrinic to request for IPv6 block. If you're an Afrinic member, you go to my Afrinic, my.afrinic.net, sign in. And then at the top of the menus, you go to request an IPv6 prefix. Yeah, but it's very straightforward. Once you log in, you go to resources and then IPv6, and you can make a request there. So I think I'm nearly at the end. If you have not completed basic configuration, you'll not be disqualified. You still have the weekend, and next week we'll try to get you to finish the courses. If you don't finish by next week, Friday, that's when you'll be disqualified. Offline PHP IPAM, yeah, you can download the VM. Even setting it up is very easy. Right? If you follow the instructions, you can set it up in your own environment. Autonomous system number, that was an answer. You're getting this when filling the feedback form. I don't know. Are you trying to help me with the feedback form also as we discuss? Yeah, I'll revisit that in case you're having a challenge. Yeah, in terms of security, that's great. Okay. Okay, failing to complete due to system errors. Please share the errors you're getting in the discussion forums. Then one hack that you can use is either try a different browser. Sometimes it helps. If you're having issues loading a course or lesson, just try a different browser and it will help, or clearing your cache will help. So last thing, because there was a question on this, I think I even had it in the slide before we call it a day, unless someone answered it for the point-to-point. Because I had a question, I don't want to leave without answering you, right? And I can even do this very quickly from the example, an example of a point-to-point link, right? So let's say you have a /64, 2001 db8 colon, that's /48, then 1234 colon /64. I want to split this into /127s. There'll be lots of them, right? But you'll be able to see the various /127s. So from 64 to 127, right? There'll be lots of them. Don't know if it will even work. Let me calculate. Yes, it's quite a number. So the first /127 is the zeros, right? So this is 16, 32, 48, 64, right? So the first /127 subnet will be : /127. And then the second one is : 1/127. So this subnet has two IPs, right? The first IP is the zeros : /127 and : 1/127. Okay. You can configure this IP, right? Some platforms will allow you to do this. Some platforms will not allow you to do that, right? So it is recommended that you don't configure that first subnet, okay? So don't use it because the first one is 0 and 1, right? So it means that if you have a router there and a router there on that point-to-point link, this side you do : 1, and then this side you do : /127, and then this side you do : 1, right? /127. You can do this on some platforms. On others, you'll get an error, but it's not recommended. Don't do this. So the next one, the second subnet is this one here, right? The : 2. : 2 is the subnet, and that subnet has two IPs: : 2 itself and 3. So 23 /127. The next one is 4. So you have 0, 2, 4, 6, 8, A, etc. Lots of them. So the good thing with this, because we said you're reserving 1/64, right? For each point-to-point link. So if you have a point-to-point link there, you reserve /64. So in IPv6, it means that for all your point-to-point links, you can have the same structure, but the only thing that will change is the actual /64, okay? So you may decide all your point-to-points will be 2 and 3, right? One side will be : 2 /127. The other side will be : 3 /127. So you can do this everywhere, but the only thing that will be different is just your /64. So I hope that is clear. Clear all my drawings. So the question was asked by, I hope I answered your question about the showing an example. That was Henrik. Is it Henrik? Okay, I can't see you again. Okay, good. So we're at the end of the session. Kindly please help me with feedback, right? Head over to that link, bit.ly zv6-live2. Help me with feedback. Debo, kindly help me check how many people have filled it in, please, before we finalize the last order of business.
Okay, let me check now.
Okay. bit.ly zv6-live2. So I see we have 202 participants here. Gomanji, you want to ask a question? Is it a question that you want to ask? Let me allow you to talk. And please be brief since we are nearly out of time. Gomanji. Yes, please.
I already asked. I
Okay.
asked the recording. Yeah. Thanks.
Okay. Good. So if it's a question about the things we've covered, please. Next one is Aloha Yohan Gumanji Olayemi. Is it about the course content we've just covered? Okay, Handward Lindile. Is it about the course content? If it's something else, just type in the chat and my colleague Debo will assist you. If it's about the accessing the platform, etc. Okay, great. Debo, we good?
Yeah, we currently have over 70 entries, and we'll see if we can make it up to 100. We would appreciate. So kindly share your feedback with us, and in the next 3 minutes, we can do the wheel of names. If you still have any question, you can drop it on the question and answer. My colleague Musa Stephen is on it. It's currently answering all the questions. So if you still have more questions, you can actually drop it on the Q&A, and the trainers will be able to. And also, I will encourage us to stay back for the wheel of names. If today we have about 3 more lucky winners, and with that, we still encourage you to share your feedback with us. So we are 83 in. We need more, about 17 to go. Let's keep it coming. When we get to the mark of 100, yeah, we have 87. So we have about 13 more to go. So I need 13 more feedback.
So as you're doing
Okay.
that, there's a question from Marcy about why will I need to increase the subnet, yet the interface ID can never be depleted / close to impossible. When you talk about the subnet, is the prefix you get from Afrinic, not the prefix that you're configuring at the subnet level, the /64. So if you're an ISP, you come to Afrinic, we give you a /32. If you're an enterprise network, you come to Afrinic, we give you a /48. So if after 1 or 2 years, you find that this prefix is not enough, you come back to Afrinic to request for a larger block, okay? And that's why we said it's important for you to do a proper estimate as you are requesting for these prefixes to avoid you needing to come back each and every now and then when you exhaust your current block, right? If you do a proper plan, you're going to be set for a very long time and you'll never need to come to Afrinic to request for a change. So the subnet is the prefix you get from Afrinic, the big block, the /32 or the /48 or the /24, which we even did an example with. Whatever prefix that you make a request, that's what we're talking about. Okay, Debo, I think we are good.
Yeah, we are good. I just need 2 more before we cut off. Just 2 more feedback and we are good. Thank you so much, Maurice, for the feedback. Thank you very much, Ismail, Chimebezkezo, Ogagba. Thank you very much for the feedback. So I need 2 more feedback before we move to the. Okay, good. Thank you so much. I have 102 in. Thank you so much, everyone. So may I share my screen, Bashir?
Yes, please.
Okay, so today, I believe everyone can actually see my screen now. So we are about to roll the wheel of names now, and hoping we have 3 more lucky winners today. So let's go. Oh, Laurent Sabo. Excellent. Florence Sabo. Is Florence Sabo on in this call? Florence Sabo. Oh, okay, awesome. Welcome. Congratulations to you, Florence Sabo. Excellent. So I'm gonna remove you, and we roll 1 more. Christabel Mebagandu. Congratulations, Christabel. Are you on this call? Is Christabel on this call? Christabel, are you Ismail? Who is Christabel? Okay, I don't think she's on the call. We might need to roll it again. So unfortunately, Christabel is not on this call. Okay, if you're on the call, kindly send us a chat or you raise your hand. Okay, I don't think Christabel is on this call. Okay, I will more than so we have two more to go. Fortunately, we have two more to go. Okay, so let us roll it again. Well seen, Alzega. Congratulations, well seen. Is well seen on the call? If you're on the call, kindly indicate on the chat or you raise your hand. Well seen. That's Ezekiel. Is well seen on the call? I doubt. Okay, so we have two more to go again. Fortunately, I don't see Wilson on this call. Okay, Wilson is not on the call. We have two more to go again. Okay. Che. Okay, I don't think this is a real name. If you're on this call, Chiche, kindly identify yourself, either by going to the chats or you raise your hand. Chiche, I doubt Chiche is on this call also. Okay, unfortunately, Chiche is not on this call. We still have two more to go, so there's still. Okay, let's roll it one more time. Bolahon Gade, congratulations to Bolahon Gade. Is Bolahon on this call? Bolahon Gade. Okay, not on the call. Okay, two more chances to go. I think today is the lucky day. Let me roll it again. Oh, White Cross. I hope so too. Okay, Roger Brustala. Roger Brustala. Is Roger Bruce on this call?
He's there. He's there.
Is there? He should please identify himself before we. Okay, Roger Brustala. Congratulations, Rogers. Okay, Roger, congratulations. Okay, well done, Roger. Let me. So we have one more to go. Emmanuel Amos. Emmanuel. Okay, Amos Emmanuel is not on this call. So we have one more to go. I see. Okay. Francois Van Nick. Is Francois on this call? Oh, excellent. So we have our 3 lucky winners, and congratulations to Florent, Roger, and Francois. So for you to have access to the voucher, you need to complete all the 3, all your courses on the cohort. So that's when you're able to have access to the voucher. So congratulations once again. Till next week, Wednesday, then we'll keep rolling and encourage every one of us. The platform is a little bit stable now, and over the weekends, I also encourage our participants to also try and complete. If you have any issues, kindly drop in a message. We'll be on the standby over the weekend to answer any query. And at the moment, we have some of our colleagues who are helping to stabilize the platform to ensure that we have full proper learning experience. Thank you very much once again to our participants and also to the lucky winners. We have a lovely weekend and enjoy the rest of your day. Bye, everyone.